Good evening, everyone. This is the third lecture in the electromagnetic theory series, where we'll be solving questions related to gate that comes in gate exam, right? So this chapter is called transmission line. Okay, that is the advanced chapter of electromagnetic theory, and 2 more questions will be coming from this chapter. Okay, and 5 marks in net, 2 marks in gate, right? So what is the transmission line? See, this is the resistance, and this is the inductance. Okay. Again, resistance, inductance, then there is this resistance, then and inductance. L, R, okay, L, R, L, R, and this one is the conductance G. This is capacitance C. The same, and this will be a wire, and this will have also here, sorry, conductance G and a capacitance C. This is your transmission line, alright, where we can write R is a what? R is your what? R is your resistance per unit length. Resistance per unit length. And L is your inductance per unit length. Everything is per unit length, okay? Inductance per unit length. Then G is your conductance and C is your capacitance per unit length. Capacitance per unit length. Alright, so this is the transmission line. So what is it? So transmission line, right? A very important sentence. Transmission line for example, we don't need to go that deep into all this. Transmission line supports transverse electric mode, transverse electric mode TEN. It's called TEN. Okay, and its range of frequency is 0 to 3 gigahertz. All right. So what are the types of transmission line? Types of transmission line. Types of transmission line. Okay. First one is for uh, for a two-wire line. For a two-wire line. All right. So this is suppose a wire. Okay. So here L is what? Inductance for 2 mu by pi ln 2d by d. Okay, this is your inductance. So capacitance here is pi epsilon naught ln 2d by d. Right, this is the capacitance per unit length. Right, this capacitance per unit length. Okay, this is for what? This is two wire line. Remember this, C is equal to pi epsilon naught ln 2d by d. Next is what? Next type is what? Next type is what? For coaxial cable. Next type is for coaxial cable. Alright, for coaxial cable, coaxial means same axis. So this is one. You know, this will be circles. Okay? This is your D, and this one is your small d, right? So here inductance per unit length mu by pi ln d by d, right? So capacitance will be 2 pi epsilon naught. You have to remember all this, 2 pi epsilon naught ln d by d. Okay, 2 pi epsilon ln d by d. Sorry, ln d by d. In case of two wire line, it was what? Two wire line. It was C is equal to pi epsilon naught ln 2d by d. In case of, sorry, why I'm giving the bracket here. For coaxial, it is C is equal to 2 pi epsilon naught what ln d by d. For two wires, it is 2d by d. There is a 2 here, there is no 2 here. There is a 2 here, there is no 2 here. Remember it this way. Okay. Yeah. So next is a what? Next is called, come on. Next is called what? Next is your characteristic impedance. Characteristic impedance. Right? Characteristic impedance. What is it? Suppose this is your conductor, alright? This is source. This is your load. Okay. So what happens here? What are the formulas? See, for for maximum power, transmission impedance transmission impedance of source and load should be matched. Should be matched. So transmission impedance of what's of source, this one and this one should be matched. Right. So the formula, if I write characteristic impedance, that is what Z impedance we write by Z. Z is equal to root over of R plus j omega L, okay, whole divided by G plus j omega L. Sorry, j omega C. Because see how to remember this one. See, this is your resistance. Along with it, L was connected. There was this conductance, and along with it, capacitance was connected. So yeah, R plus j omega L. Okay, if you remember, Z is equal to what? Z is equal to R plus, sorry, R plus what is it? R plus j omega L divided by G plus j omega C root over. Alright, where G is a what? Conductance per unit length. Sorry, conductance only. Okay, and J is your minus 1 root over. This is we write here as I. We don't write I here because I is also current. So we write J. Okay. So this is a what? Characteristic impedance. Alright. Now, now there is a condition, low loss condition. Low loss condition. Low loss condition is R is equal to 0, G is equal to 0. Okay. So it will make it Z naught is equal to, see, R is equal to 0, Z is equal to 0. So it leaves us with j omega L by j omega C root over, which is L by C root over, isn't it? So J naught is equal to L by C root over. Okay. So this is low loss condition. Now distortion loss condition. sorry, distortion loss condition. Okay, distortion loss condition will be what? R by G is equal to L by C. Hmm. That means resistance divided by conductance is equal to inductance divided by capacitance. So if this happens also, the Z naught will be how much? Root over of what? L by C. Okay. So these are the conditions you need to remember. Okay. Next formula is what? Next formula is propagation coefficient. Propagation coefficient. So this is a very formula based topic, this transmission and all. Propagation coefficient is gamma. Okay, we denote it by gamma. It will be simply R plus j omega L whole into G plus j omega C. See, the division of R plus j omega L divided by G plus j omega C was how much? That was your impedance, characteristic impedance. But the multiplication of is called what? Propagation coefficient. Okay, gamma is equal to root over of R plus j omega L whole into G plus j omega C. Okay, yeah. So again, low loss. What is your low loss condition? We know low loss condition. If you go to previous slide, if your low loss condition is how much? You can see here R is equal to 0, G is equal to 0. So let's write it down here. R is equal to 0, G is equal to 0. R is equal to 0, G is equal to 0. So put it here. So you will get gamma is equal to how much? Root over of 0. So j omega square into LC. So j omega will come out j omega root over of LC. Okay. So gamma is equal to j omega root over of LC is what? Your propagation coefficient when R is equal to 0, G is equal to 0. That means low loss condition. Right. Next was what? Distortion loss condition. Right. Next was what? Distortion loss condition. Okay. Distortion loss condition. Okay. So distortion loss condition was what? Sorry. Distortion loss condition. So distortion loss condition was what? It was R by G is equal to L by C. Okay. So if I put it there, gamma will be what? Root over of LC R by L plus J omega. Alright. Propagation coefficient. For low loss condition, again if I write, what is the condition? R is equal to 0, J is equal to 0, G is equal to 0. So gamma is equal to what? J omega root over of LC. So these are the two conditions we need to remember to solve questions. Alright. Now the last formula in this, last condition in this will be your reflection coefficient. Alright. Reflection coefficient. So reflection coefficient is what? T is equal to ZL by ZS, ZL minus ZS divided by ZL plus ZS. So this is your what? A reflection coefficient. Okay. This is what? A reflection coefficient. Alright. Yeah. So now we'll do questions related to all of this. These were just the concepts, not even concepts. I just told you all the formulas. So if we go to the questions now, so this is the first question. See, read the question carefully. Read the question. The conductors in a 0.75 kilometer long two-wire transmission line. Okay. This is a two-wire transmission line. This is a two-wire transmission line. So conductors in a 0.75 kilometer long two-wire transmission line. What was happening in two-wire transmission line? C is equal to pi epsilon naught divided by ln 2d by d, isn't it? That was your two-wire transmission line, isn't it? But this is your what? This is your capacitance per unit length. Capacitance per unit length. If I multiply the length with it, that will give me the whole capacitance, isn't it? So if I multiply length, that will give me the whole capacitance. So I will write. So what is the question? If each conductor has a diameter of 4 centimeter, so diameter is given. Diameter is given d. Small d is diameter 4 into 10 to the minus 2 centimeter. All right. And what is given also? Two-wire transmission line are separated by a center to center distance of 0.2 meter. So d is your center to center distance. You can write here if you are confused. D, write down d is equal to center to center distance. D is equal to center to center distance, and small d is equal to what? Diameter. Small d is diameter of what? Small d is diameter, alright, of each conductor. Alright. So for two-wire transmission line, C is equal to this one. So can you tell me the other one, other formula? That was for other one. That was C is equal to 2 pi epsilon naught. Which condition it was? This was for coaxial one. ln d by d only, wasn't it? So this was the what? For coaxial cable. Alright. For two wire, why I'm writing it again and again, because so this way you will be able to remember the formula for two wire system. So now nothing is there to do. Just put the form values pi epsilon by ln 2 into what is capital D. Capital D is end to end or center to center distance, that is 0.2 meter, divided by small d is what? Diameter. Diameter is how much? 4 into 10 to the power minus 2. So pi epsilon pi is how much? 3.14 into 8.85 into 10 to the minus 12 divided by ln 0.4 divided by 0.04. Right, if you calculate it, if you simplify it, you will get C is equal to 88.5 nanofarad. Okay, this is how much you will get. Okay. Do this, okay? Don't write it down just like this. So these are the two formulas you really need to remember. 2 mark questions will come in GATE and 5 marks in NET. Okay, yeah. Yeah. Next question. Two long hollow coaxial conducting cylinders of radius radii R1 and R2 are placed in vacuum as shown in the figure. So the inner cylinder arrives from what? Carriers say carries. This is carries. Okay? Carries a charge per plus lambda per unit length, and the outer cylinder carries a charge minus lambda per unit length. The electrostatic energy per unit length. Electrostatic energy U per unit length of the system is how much? That is asked in the question. Alright. So this is a coaxial conducting cylinder. Coaxial, let me write it. Coaxial conducting cylinder. So this is kind of coaxial cable. So for that, what is it? Coaxial, for coaxial tube, like tube, whatever capacitance was what? 2 pi epsilon naught ln capital D by D. Okay, 2 pi epsilon naught capital, ln capital D by D. But what we have to do with capacitance? How do we need capacitance? Because we need electrostatic energy per unit length. So electrostatic energy Electrostatic energy is how much? U is equal to what? Half into Q into V. Okay, half QV. I can also write it. Can I also write it? Q into Q by C, isn't it? So it becomes Q square by 2C, isn't it? Q square by 2C. So now everything is there, isn't it? Now everything is there. C. So energy is equal to Q square by 2C is equal to Q square by 2 into 2 pi epsilon naught ln d by d. Alright. So ln d by d. Here what is C? This is your cylindrical cube, and this is another one coaxial. That means that this like same axis. This is the same axis, both of them, and this distance is your r1. This distance is your r2. So I can say your capital D is your r2. This one is your small d, isn't it? So I can write it as q square by 4 pi epsilon naught divided by ln r2 by r1. This will go up. So q square by 4 pi epsilon naught into ln r2 by r1. Okay, ln r2 by r1, right? And yeah, we don't need to put in the values. That's in the option. Let's see. Q square by 4 epsilon ln r2 by r1. Okay, here q. So here what is it? Charge per unit length is okay. Okay, yeah. Charge per unit length is lambda. So like q square by l square will be how much? Lambda square only. So you can write it as lambda square by 4 pi epsilon naught ln r2 by r1. You can ask me, so where is L square? Because on this side we will do L, right? Yeah. So lambda square 4 pi epsilon naught ln r2 by r1. This is the answer. Electrostatic units per unit length. Alright. So this is a what? Transmission line. Alright. This is from transmission line. So what were things we need to remember for transmission line? If I recap it again, so if I recap transmission line, sorry. अरे यार, sorry for this. Okay, if we recap the transmission line, so only 2-3 things we need to consider. That is your what, two wire system. C is how much? I'm writing it again. Then your coaxial one. C is how much? 2 pi epsilon naught ln d by d. Okay. Then what is there? Then your reflection coefficient is there. Reflection coefficient is there. T is equal to how much? Tell me. T is equal to ZL minus ZS is divided by ZL plus ZS. That means impedance of inductance divided, like impedance of load divided minus impedance of source. Okay, then propagation coefficient R plus j omega L or into R G plus j omega C. So we are multiplying these two terms in the propagation coefficient, but we are dividing it in what? We are dividing it in impedance, like characteristic impedance. We are dividing these two terms R plus j omega L divided by okay, G plus j omega C. All right. Yeah. Then low loss condition, low loss condition is what? R0 G0. Then distortion loss condition is how much? Um, tell me, L is equal to 0, C is equal to 0, right? No. R by G is equal to L by C. Okay. So this is the summary of transmission line. All right. This is the summary of transmission line. All right. So next we will study waveguide. Okay, just wait again. I'm really sorry for this. I forgot to give the new slides. All right. So this is it. So now next in this exact same topic is waveguide. Okay, give you any waveguide. Very important. So waveguide, first of all, this is the equipment used to guide the electromagnetic wave for sending the signal from one region to the other. Okay. So waveguide supports what? Waveguide supports both TE and TM mode. Alright. And what is the range of it? The range of it is 3 to 300 gigahertz. Alright. So now first one is rectangular waveguide. Rectangular waveguide. First one is rectangular waveguide. Okay. For rectangular waveguide it's like this, something like this. X axis, Y axis. Okay. This is like something like this. Z is BA. Okay. This is origin. BC. So surface is made of conductor here. Okay. Right. This is a rectangular waveguide. Next is a what? Transverse, the T mode. The that is your what? Transverse electric mode. Transverse electric mode, TEM. Okay. So transverse electric mode here, what happens? Electric field Ez is equal to 0, but Bz is not equal to 0. Okay. But what is Bz then? Bz is B naught cos m pi x by a into cos n pi y by a. B naught cos n pi x by a into cos n pi y by a. Okay, this is a Bz. Have to remember this. This is a Bz. Now cutoff frequency is what? Cutoff cutoff frequency. Cutoff frequency is f is equal to c by 2. F is equal to c by 2 m by a whole square plus n by b whole square. Okay, m by a whole square. This one, just this m by a whole square here, n by a whole square, n by b whole square. This one, my bad, is n by b. Okay, by b whole square. This is a what? Cutoff frequency. We know omega angular frequency is 2 pi f. So you can simply write it as what? Pi c root over of m by a whole square plus n by b whole square. Okay. Alright. So now next is lowest cutoff frequency. Lowest sorry lowest cutoff frequency. What is lowest cutoff frequency? Lowest cutoff frequency is omega mn is how should be how much? Omega 10 is equal to omega 01. Okay, whereas omega 10 is pi c by a. Okay, omega 10 is how much? Pi c by a. Okay, how would you calculate omega mn is how much? Omega mn is pi c root over of m by a whole square plus n by b whole square. So pi c omega 10. So 1 by a whole square plus 0. That means pi c by a. Exactly like that, omega 01 will be how much? Pi c root over of 0 square plus 1 by b whole square. That would be pi c by b. That would be what? Omega 01. Hmm. Okay, but this is your what? This is called lowest cutoff frequency. Lowest cutoff frequency. Alright, this is called your lowest cutoff frequency. Yeah, okay. Next. Okay, next is what? Next is what? Remember c square k square is equal to omega square minus omega mn square. This is the formula. Okay. So what is the waveguide wavelength? So waveguide wavelength is lambda is equal to how much? Lambda g. Okay. Waveguide lambda g is equal to lambda naught divided by 1 minus 1 minus lambda naught by lambda c whole square. This is a what? Lambda g. Lambda g again. Lambda g is equal to lambda naught root over of 1 minus lambda naught by lambda c whole square. Okay. Whereas lambda c is what? Lambda c is c divided by c by 2 root over of m by a whole square plus n by b square. Okay. Yeah. Now then. Now this was the previous one was transverse electric mode, right? TEM gone. Now transverse magnetic mode. TM mode. Transverse magnetic mode. Transverse magnetic mode. TM mode. Okay. So TM mode is how much? Here Ez will not be equal to 0, but your Bz will be 0. In TEM what was happening? Ez was 0, but Bz was never 0. But here Ez not equal to 0, Bz is 0. So here Ez will be right. So E naught, see here it will be sine m pi x by a into sine n pi x by b. What is happening in TEM mode? In TEM mode, Bz was what? B naught cos m pi x by a into cos n pi x by b. But in TMM mode, Ez is equal to E naught, this one. Okay. So we can write in a summary kind of thing like TEM, TMM. So TEM is transverse electric mode where your electric field was 0, but magnetic field was not. Okay. And magnetic field can be written in terms of cos m pi x by a into cos n pi x by b. In transverse magnetic mode, Ez is not equal to 0, but Bz is 0. So Ez should be what? E naught, but here it is sine m pi x by a into sine n pi x by b. Alright? Yeah? Okay. Now in TMM also, omega will be how much? Pi c root over of m by a whole square plus n by b whole square. Okay. Lambda c will be how much? 2 by root over of m by a whole square plus n by b whole square, which is the same as TEM also. Omega is pi c root over of m by a whole square plus root over plus n by b whole square, and lambda c is equal to 2 by root over of m by a whole square plus n by b whole square. Is it right? Right? Yeah. So here lowest possible mode in TMM will be what? TM lowest possible mode lowest possible mode in TMM, m is equal to n is equal to 1. Okay, so omega 1 is equal to pi c root over of 1 by a square plus 1 by b square. Okay, how did you get it? Simply wmn omega mn is pi c root over of 1 by a whole square m by a whole square plus n by b whole square. In place of m we just put 1, in place of n we just put 1. We got omega 1 is equal to pi c root over of 1 by a whole square plus 1 by b whole square. All right? Yeah. Okay. Okay, next there is an important note. Just write down important note. Mm, what is going on? Just important point. Write down the important point. That is uh, if if TE and TM mode if TE and TM mode both propagate, then what happens is then TE, that is transverse electric mode, actually propagates first. Okay, propagates first. Okay, so lambda c 10 TE is greater than lambda c 11 in TM, because if you see the lowest possible value in TE was 10 and lowest possible value in TM is 11. That's why I wrote lambda c 10 T E greater than lambda c 11 TM. Okay, yeah. So let's do questions. Okay, yeah. So this is the question from Waveguide. See, the magnetic fields of TE mode of a rectangular waveguide of dimension a cross b, as shown in the figure, is given as how much is it given? Hz. Okay, Hz is equal to h naught cos. See, the magnetic field in terms of cos 0.3 pi x into 0 cos 0.4 pi y. What is the question? The dimension of the waveguide. Dimensions dimensions of the, I think it's not right, but just of the waveguide. So tell me first, can you write the original waveguide? That is b is equal to bz b naught cos m pi x by a into cos n pi x by b. Right? So m by a will be what? M by a will be m by a will be what? M by a will be here given 0.3, 0.3. N by b will be what? 0.4. All right. So m by a is equal to 0.3, n by b is equal to 0.4. So it's given what? TE double one more. TE 1 1. That means what? M is equal to 1, n is equal to 1. So see how easy it is. So 1 by a is equal to 0.3. M by a is 0.3 na. So m is 1. So 1 by a is 0.3. A is equal to what? 1.1 by 0.3, that is 10 by 3. That is 3.3. Okay, from here option 1 is only a 10, 3.3. Then also if we check n by b is equal to what? 0.4. So n is what? N is 1. 1 by b is equal to 0.4. So b is 1 by 0.4, that would be how much? How much? 2.5, I think. Right? 2.5 centimeter. Yeah. So this is the answer. Option A is the answer. A is 3.3, B is 2.50. Okay. We just use the concept what? In TE mode, EZ is 0, but BZ is not 0. So BZ is how much? BZ is how much? B naught cos m pi x by A into cos n pi x by, sorry, n pi y by B. I'm making the mistake again and again. This is y actually. I have written it x everywhere. Okay, my bad. Yeah. Okay. So this is one question. All right. Next question. Next question is the entire range of frequency for which TE a 1 mode will propagate. Okay, entire range of frequency. How will we do it? We just calculated A is equal to 0. I think okay, A is equal to 3.33 centimeter, and B is equal to how much we calculated? 2.5 centimeter. Okay, M is equal to 1, N is equal to 1. So entire range of frequency we just need to calculate. That is how much? F, simple question. Fmn is equal to what? C by 2 root over of M, sorry, M by N, M by A whole square plus N by B whole square. Simple. So this is your what? 1.5 into 10 to the power 8 whole root over of 1 by 3.33 whole square plus 1 by 2.5 whole square. So this is actually what? 1.5 10 to the power 8. This was actually what? Your 3, right? So 3 square, that is 9, plus 4 square, that is 16. 25 root over is 5. So 7.5 into 10 to the power 8, you have to do it first. Okay, you have to do it this way. Hertz. That means 75 what? Gigahertz, isn't it? Or did I do any mistake? Did I do any mistake? Okay. This was 30. Okay, I get it. This would be 9 here. This is, yeah, I get it, I get it. So this is 7.5. Okay, so 7.5 gigahertz is what? This is a what actually? FC11. This is a what? Cutoff frequency, isn't it? This is a cutoff frequency. That means like frequency should be greater than this. This is the minimum one. Cutoff means minimum here. So it should be minimum, like greater than this, isn't it? Do you get it? Do you get it? All right. Next question. Next question is: consider a rectangular waveguide with transverse 2 meter into 1 meter driven with an angular frequency of omega is equal to 10 to the power 8 radian per second. Which transverse electric modes will propagate in this waveguide? All right, we have to check. This is 2 cross 1. That means what? A is given 2 meter, B is given 1 meter. Isn't that right? Is that right? Yes. So we know omega is how much? What is the formula for omega? Pi c root over of m by a whole square plus n by b whole square. Okay. So pi c. So first we have to check for TE10. So pi c 1 divided by 2 whole square plus this is 0, na? 0. So pi c by 2. So this is omega. Pi c is equal to pi c by 2 for what? 1 0. Okay. If you put the values 3.14 into 3 into 10 to the power 8 divided by 2, you will get it as 4.7 into 10 to the power 8 radian per second. Okay. Well, what is the question? Which transfer will propagate in this waveguide? Okay. Propagate in this waveguide. Alright. So we have to check one by one. You have to check one by one. The ones that are coming in the range 10 to the power 8, you will consider. All right. You will like that. You will check 0, 1, omega 2, 0, omega 1, 1. All right. So the ones that will come in the range of 10 to the power 8, you have to check. All right. Yeah. And what is the order? Order means which is greater, which is small. That's what you have to do here. Yeah. So this is the way to solve questions from transmission line and waveguide. Right. So now I think we'll be able to solve the questions that come in the previous years. So try to solve everything from transmission line and waveguide. Okay, from gate and net both. Okay, gate and net. It's too easy. It's not that hard. We did it really well. Okay, all the questions. Okay, okay then. I think that will be it for this class, and we'll be solving more questions from EMT in the next sessions. Right. Thank you. Thank you very much.